morning, the Arabian Sea, the USS Gerald R. Ford is cutting through open water at 30 knots, and somewhere deep inside its steel hull. A kitchen is on fire, not literally, but in every way that matters. $65,000 in groceries consumed before the sun comes up. 17,300 individual meal servings produced every single day. 20,000 cups of coffee dispensed across 4 separate meals: breakfast, lunch, dinner, and a 4th meal most people have never heard of, served for the crew standing watch while the rest of the ship tries to sleep. 4 meals a day, 7 days a week, 270 days straight, with no days off, no holidays, and no option to close early. That is the number. Now here's what the number does not tell you. The USS Gerald R. Ford cannot pull into a port to restock. It cannot stop at a distribution center. It cannot call delivery service. Everything that 5,000 human beings consume across a 9-month deployment must come to them across open ocean, in all weather, without pausing flight operations, without slowing down. Every 7 to 10 days, a dedicated combat storage ship, typically a Lewis and Clark class dry cargo vessel, approaches the Ford from behind, matches its speed through open sea, and the 2 ships travel in parallel formation, close enough that a cable can be strung between them. Between 400,000 and 700,000 pounds of food cross that cable per replenishment. Both ships are moving. The ocean is moving around them. And somewhere in the space between 2 steel hulls, hundreds of thousands of pounds of frozen protein, fresh produce, and canned goods are swinging through the air on a line. That process is called underway replenishment, UNREP, and it is, without exaggeration, a military operation in its own right. Think about what that number actually means in human terms. A standard American household spends roughly $7,000 on groceries per year. The Ford burns through that figure before 10. Boom. The entire ship's food budget across a single deployment exceeds $1.8 million per month, sustained for 9 months, in an environment where the nearest functioning supermarket is several thousand miles away. What the Navy built to make this work is not a kitchen. It is a continuous cycle industrial food manufacturing operation disguised as a galley, running inside a warship, staffed by between 93 and 114 culinary specialists trained at the Naval Station in Fort Lee, Virginia. They do not cook 3 meals a day. They cook 4. And some part of that operation is running at every hour of every day for the entire length of deployment. His rating is culinary specialist. His pay grade is E4. His shift started 14 hours ago. The galley he works in runs at an ambient temperature of 135 degrees Fahrenheit, hotter than the lowest bake setting on a standard home oven. And he has been standing in it since before most of the ship woke up. He is not a chef by the Navy's definition. He is a logistics operator who happens to work with food. But right now, at 2:30 in the morning, he is doing something that no logistics manual required him to do. He is decorating a birthday cake. Not for a friend, not for someone he knows. For a sailor whose name appeared on a roster, whose date of birth was flagged by a tracking system, and whose birthday happens to fall on this day, 300 miles off the coast of a foreign continent, during active deployment. The Navy has a policy: every birthday gets a cake. All 5,000 plus of them, tracked individually, produced individually, delivered individually. This man is the reason that policy is not just a line in a regulation. The culinary team operates on a 21-day rotating menu designed by Navy nutritionists, federally mandated for caloric content, individually tracked for allergen accommodations and religious dietary requirements across a population of 5,000 people, with no outside restaurant as a fallback. Males are allocated 2,850 calories per day. Females, 2,100. The system is precise, engineered, and relentless until the sea decides otherwise. When the Arabian Sea kicks into sea state, 5 waves exceeding 6 meters, sustained swells that make standing at a stove a physical danger, the entire engineered menu collapses. Hot food becomes impossible. The stoves are secured, the galley shuts down its primary operations, and the most expensive warship ever constructed, a $13 billion vessel powered by 2 nuclear reactors, serves its crew cold sandwiches, and bottled water, because the ocean does not care about the menu cycle. But food is only the first layer of this problem. The second layer is far stranger, because it turns out that the water you drink on an aircraft carrier is competing directly with the machines that launch fighter jets. And in that competition, you are not winning. Every single day, the USS Gerald R. Ford produces approximately 400,000 gallons of fresh drinking water. Not from a tank, not from a resupply ship. From the Arabian Sea itself, salt water pulled directly from the ocean, fed into a system of flash evaporators powered by the ship's two A-1B nuclear reactors, superheated under controlled pressure until it vaporizes, then condensed back into fresh water with the salt removed. 400,000 gallons. That is enough to fill roughly zero. 6 Olympic-sized swimming pools every 24 hours, generated continuously, automatically, regardless of whether the ship is in the Western Pacific, the Persian Gulf, or the North Atlantic. On paper, that sounds like more than enough for 5,000 people to drink, cook with, and bathe in. The paper is wrong. Somewhere below the waterline, in a machinery space where the temperature routinely exceeds 110 degrees Fahrenheit, a machinist's mate rating MM, pay grade E5 sits a watch that most of the ship never thinks about. His job is to monitor the output of the distillation system in real-time flow rates, salinity levels, pressure readings, production volume. If the numbers drop, he reports it. If a component fails, he responds. He does this on a rotating schedule, around the clock, every day of the deployment. The 400,000 gallons that the ship's crew depends on does not appear by itself. It is managed, tracked, and protected by people whose names never appear in any public reporting about the carrier. The water does not run because of the reactor. It runs because someone is watching. Here's the part of the water conversation that the Navy does not advertise. Of those 400,000 gallons produced daily, the sailors aboard the Ford are last in line to use them. Not second, not third, last. The actual consumption hierarchy, in order of operational priority, runs as follows. First, the propulsion system. The Ford's two A-1B reactors require continuous feed water to generate steam that drives the ship's 4 shafts. That demand is non-negotiable. Second, the electromagnetic aircraft launch system emails the Ford-class replacement for the steam-powered C-13 catapults used on Nimitz-class carriers. Every launch cycle draws from the ship's electrical and thermal systems in ways that place downstream pressure on water management across the entire vessel. Third, aircraft washdown. Every jet on the flight deck receives a daily fresh water rinse to remove salt spray. Salt corrosion on an F/A 18E/F Super Hornets avionics and airframe begins within 48 hours of exposure. The washdown is not a comfort measure. It is a maintenance requirement that keeps a $67 million aircraft airworthy. Fourth, the galley and sanitation systems. Fifth, at the bottom, personal hygiene. Your 2-minute shower is the residual. It is what is left after everything operationally critical has taken its share. The Ford class was designed to be more capable than the Nimitz class in every measurable category. Emails delivers a smoother, more controllable launch stroke than the C-13 steam catapult, reduces stress on airframes, and eliminates the massive steam accumulators that consume significant internal volume on older carriers. It is, by most engineering metrics, a superior system. But between 2017 and 2019, emails experienced repeated reliability failures during the Ford's post-commissioning testing and early deployment cycle. The system that was supposed to launch aircraft more efficiently was instead grounding them, not because of combat damage, not because of enemy action, but because the technology was not yet mature enough to perform consistently under operational conditions. During those periods, the ship's ability to conduct flight operations was directly constrained by the reliability of a system that had never been tested at full scale before it was installed on a $13 billion vessel. The most advanced carrier in history was limited not by its adversaries, but by its own engineering ambition. The procedure is called a Navy shower, and it has existed in naval doctrine for decades. 30 seconds to get wet, Water off. Soap applied head to toe, shampoo worked in, everything scrubbed, water back on for a final rinse lasting no more than 90 seconds. Total elapsed time under 2 minutes. A standard American shower runs 8 to 12 minutes and consumes approximately 20 gallons of water. Multiply the difference by 5,000 people every day for 270 days, and the math becomes self-evident. But the math is not the real story. The real story is what it feels like to stand under that water after a 12-hour shift on a flight deck in the Arabian Sea heat, knowing that you have 90 seconds before you need to turn it off, not because a regulation says so, but because somewhere above you, a $67 million jet needs to be rinsed, and the water that rinses it came from the same place your shower does, and the jet goes first. You think 2 minutes underwater is the hardest part of living on this ship? Wait until you hear what they do with everything that comes out of 5,000 people every day and what happens when that system breaks. Water is a combat resource. But beneath the waterline, a different kind of pressure is building, one that has nothing to do with plumbing and everything to do with who you are, what rank you wear, and which table you're allowed to sit at. The Ford does not carry one crew. It carries 3 distinct populations sharing the same hull, the same recycled air, and the same nuclear-powered water, but experiencing almost none of the same daily reality. Approximately 3,200 enlisted sailors form the base layer, doing the physical work that keeps every system alive. Above them, roughly 500 commissioned officers occupy a parallel world that intersects with the enlisted population only at the edges. Layered across both groups, 2,500 Air Wing personnel operate under their own chain of command and their own internal hierarchy. OPNAVINST 3120.32 specifies with bureaucratic precision who eats where, sleeps where, and exists where from pay grade E1 to O10. The separation is not implied. It is written down, enforced, and intentional. For an E1 through E6 sailor, eating means the general mess, a long cafeteria line, a plastic tray, and approximately 20 minutes between the end of the queue and the start of the next watch. A sailor coming off a 12-hour flight deck shift does not sit down to a meal he processes through a line, locates an open seat, eats standing if it is crowded, and returns the tray to a conveyor belt. There is no alternative. There is no option to skip the line. For 9 months, that cafeteria is the only food establishment accessible to the majority of the people keeping the ship operational. One deck up, officers from O1 to O6 eat in the wardroom blue tablecloths, padded chairs, assigned seating, stewards who bring food to the table. Friday brunch is a weekly ritual of normalcy, engineered to give junior officers something to anticipate inside the grinding sameness of deployment. The Navy maintains this separation, not as legacy tradition, but as active psychological design. Military research consistently shows that rank must carry perceptible daily value to sustain the incentive structures driving re-enlistment and unit cohesion. At the top, the commanding officer eats in the captain's cabin with a private chef and a menu that has included duck confit and individually plated French desserts. The same hull, the same reactor, 3 completely different dining experiences. The tablecloth is not a comfort. It is structural. The stratification does not stop at the table. A junior enlisted sailor lives in a berthing compartment with 40 other stacked racks measuring 183 centimeters long, 61 centimeters wide, 61 centimeters of vertical clearance above the face. A canvas curtain is the only physical boundary between that sailor and the rest of the world. One external locker, no door, no lock. Senior officers occupy single or double occupancy staterooms with actual doors, actual locks, and in some cases a porthole, a window to an outside world that sailors in interior engineering spaces may not see for 14 consecutive days. The system has one fracture point that no regulation anticipated. When the Ford enters MCON emissions control, the ship cuts all electronic transmissions to avoid detection. In that condition, a lieutenant commander cannot call his wife. A captain cannot check on his children. A petty officer cannot tell his mother he is alive. The blue tablecloth remains. The private stateroom remains. But the one thing that genuinely separates a senior officer's daily experience from a junior sailor's maintained contact with the life waiting at home disappears for both of them simultaneously. MCON does not recognize rank. A petty officer first class at E6 may carry 15 years of operational experience and technical qualifications that took a decade to earn. He still carries a plastic tray through the general mess line. An ensign at 01 6 months out of the Naval Academy sits in the wardroom with a tablecloth and a steward. The Navy built this contradiction deliberately and defends it with organizational psychology research. Whether that rationalization holds across 9 months of accumulated fatigue is a question the institution answers differently than the individuals living inside it. Is this system fair? Your answer will change completely once you understand what happens when the one resource that rank cannot allocate finally runs out. Because after food, after water, after hierarchy, the thing every one of these 5,000 people is equally short of and equally unable to buy their way out of is sleep. The Ford class reduced berthing from 180 sailors per compartment to 40, the single most significant quality of life improvement in carrier design history. Each berthing now includes a dedicated head and a separate Wi-Fi lounge. By carrier standards, a genuine leap forward. By any civilian standard, it is still 40 people sleeping in stacked shelves inside a steel hull with no natural light and no acoustic separation from the mechanical systems running continuously around them. The Navy's Bureau of Medicine and Surgery has formally documented what this environment produces after 72 hours of cumulative sleep deprivation. A pilot's decision-making capacity degrades to the functional equivalent of a 0.05% blood alcohol level. Not feeling tired, clinically impaired, he is an aviation bosun's mate, E3 19 years old. His rack sits directly below one of the arresting wire stations, the system that catches a landing aircraft and decelerates it from 150 miles per hour to 0 in under 2 seconds. When an F/A 18E/F traps the wire above his head, the acoustic impact registers near 150 decibels at the source. He is not standing next to it. He is lying horizontally 2 meters below it, separated from it by a steel deck and a canvas curtain. His off-watch period is officially 8 hours. The flight schedule does not negotiate with his sleep. The Navy formally incorporated fatigue management into OPNAVINST 3120.32, the document governing how a warship is organized and operated. Standard rotation calls for 5 hours on watch, 10 hours off. In practice, during high-tempo flight operations, that cycle is the first thing that breaks. Maintenance requirements, equipment failures, and the compounding demands of sustained combat air operations regularly compress the off-watch period in ways the written standard does not sanction, but operational reality imposes anyway. The instruction exists because the Navy identified the problem. The instruction being in print does not mean the problem is solved. In 2017, the USS Fitzgerald collided with a container ship off Japan, the USS John S. McCain struck a tanker near Singapore. 17 sailors died. Both investigations returned findings linking crew fatigue and degraded situational awareness directly to accumulated sleep deprivation across extended operational tempos. The Navy subsequently revised watch rotation standards and commanding officer accountability frameworks across the surface fleet, acknowledging in formal regulatory language what sailors have been saying informally for decades: a crew that cannot sleep will eventually make a catastrophic decision. When the Ford operates inside a high-threat carrier strike group operating area, the entire crew exists in a state of conditional readiness that does not pause for sleep cycles. General quarters can be called at any hour for any duration. A sailor who completed a 16-hour maintenance shift may be at his battle station 3 hours later. There is no exemption for accumulated fatigue. The ship's survival takes absolute precedence over the physiological needs of every individual aboard, and sometimes requires that all 5,000 of them be awake and decision capable at the precise moment their bodies have the least capacity to deliver it. The Navy officially classifies food quality, berthing conditions, and sleep adequacy as combat readiness components, not crew welfare, not benefits. An army that cannot eat degrades within 48 hours. An army that cannot sleep makes lethal errors within 72. Every military force in history that treated these requirements as luxuries discovered they were structural load and discovered it at the worst possible moment. Every birthday cake produced in a 135-degree kitchen for a sailor whose name appeared on a tracking roster is the institutional acknowledgement of that knowledge in its most distilled form. The most powerful warship ever built cannot function without ensuring the 5,000 people inside it are fed, rested, and reminded at least once a year that someone on this ship knows they exist. If the most capable military force in human history cannot sustain operations without obsessing over how its sailors sleep, what does that say about every empire that decided those things did not matter? They all had the weapons. Most of them are gone.